Chapter Electricity, Class 10th, page number 221. Question number 13. A hot plate of an electric oven connected to 220 volt line has two resistances called A and B, each of 24 ohm resistance, which may be used separately in series or in parallel. What are the currents in three cases? So here we are given V equal to 220 volt, two resistances RA, RB, both are equal to 24 ohm. Now we have to find out the current when they are connected separately or in series or in parallel. So case A, when one resistance is connected like RA or RB, 24 ohm, and V is 220 volt. According to Ohm's law, V equal to IR. So here I is to be found. So 220 divided by 24, that will give 9.16 ampere. Now case B, when two resistances are connected in series, so R series will be sum of the two. So 24 plus 24, that is 48 ohm. In this case, I will be V upon R series, and that is 220 divided by 48, which will give 4.58 ampere. Now case third, when they are connected in parallel, so R parallel will be 12 ohm, 1 upon 24 plus 1 upon 24 is 1 upon RP. So here this will be 24, 1 plus 1, that is 1 upon RP. So RP equal to 24 divided by 2, that is 12 ohm. So RP is 12 ohm and voltage is given as 220. So we have to find out current in this case. So 220 divided by 12 will give 18.32 ampere. Now let's go to next question. Question number 14. Question number 14 says, compare the power used in 2 ohm resistor in each of the following cases. So case 1, here 6 volt battery in series with 1 ohm and 2 ohm resistors. So we are given 1 ohm, 2 ohm resistors, and there is 6 volt battery here. Now we find current. So I equal to V upon R series. So here V is 6 and R series will give 1 plus 2, that is 3 ampere. Now we have to find out power across 2 ohm. So P will be equal to I square R. I is this. Here not 3 ampere, but it should be 2 ampere. 6 divided by 3 is 2 ampere. So 2 square multiplied by 2, that is 8 watt. Now consider second case. In second case, we are given 12 ohm resistor and 2 ohm resistor in parallel, and then there is battery of 4 volt. So here we have to find out the power across 2 ohm resistor. So in this case, we can directly apply the formula P equal to V square upon R. So voltage for this 2 ohm resistor is 4 volt. So 4 square divided by 2. So that is 16 divided by 2 will give 8 watt. Now let's go to next question. Question number 15. Question 15 says two lamps, one rated 100 watt and at 220 volt and the other 60 watt at 220 volt are connected in parallel to each other to main supply. What current is drawn from the line if the supply voltage is 220 volt? So situation is like this. This is L1 whose power is 100 watt and there is another bulb L2 whose power is 60 watt and they both are connected in parallel to a supply of AC supply of 220 volt. Now, so we have P1 power of first one is 100 watt and P2 is 60 watt. So we find current I1 which is equal to P1 upon V. So P1 is 100 divided by V, voltage is 220, which is 0.45 ampere. Then we find I2, which is P2 upon V, and P2 is 60 divided by 220, which gives 0.27 ampere. Our purpose is to get total current I, which is sum of I1 plus I2. So I equal to I1 plus I2. So this will be equal to 0.45 plus 0.27. That will be equal to 0.72 ampere, which is our answer. Thank you.